Significant figures refer to the digits of a number, beginning with the one which is to the extreme left and it's not zero, and ending with the one that is the extreme right, which is also not zero. But if it's zero, then it is a zero that is considered to be exact. Now, these are the rules that we use in defining or identifying significant figures. First rule is that all non-zero numbers are considered significant. In other words, if a number has or consists of digits which are non-zeros, then all those digits are considered significant. For example, if we take this number 7617, that is 7,617, then you realize they are all non-zero, and therefore this number has 1, 2, 3, 4 significant figures. The second rule is that zeros between 2 and 0 digits are significant, meaning if we find zeros which are written between digits which are not zeros, then we consider those zeros to be significant. Take an example of this number we have here, 9,010,113. This zero is written between two non-zero numbers, and those numbers are digits, and that's digit 9 and 1. Similarly, this zero here is written between two non-zero digits, which is this one and this one here. So in that case, we shall have to count these zeros as being significant, meaning that this number will have 1, 2, 3, 4, 5, 6, 7 significant figures. The third rule is that leading zeros, meaning zeros which are to the left of the first non-zero digit, are not significant. Leading zeros are not significant. What are leading zeros? These are the zeros which are written to the extreme left of a non-zero number in a whole number. If we take this example here, we have 0076. So you realize this is a whole number, but there's some two zeros which are written to the extreme left of these non-zero numbers. So in this case, these are leading zeros, and therefore we don't count them as significant figures. So in this case, this number will have 1, 2 significant figures. Similarly, if we look at this number 0.0000421, you realize that these zeros here, all of them, beginning from this one all the way up to here, they are written to the extreme left of a non-zero number, meaning they are leading zeros and they are not considered significant. Therefore, this number has 1, 2, 3 significant figures. The fourth rule is that trailing zeros, which are actually zeros which are written to the right of the last non-zero digit. So trailing zeros to the right of a decimal are significant. Trailing zeros to the right of a decimal are significant. So if we take this example here, we have 13.000. You realize that these three zeros are written to the right of the last non-zero digit, which is 3. And since the number consists of a decimal point, and that means then we shall count these zeros as significant. So that means the number will have all has 5 significant figures: 1, 2, 3, 4, 5. Another example is 0.810000. So these 5 zeros are written to the extreme right of this non-zero digits, meaning they are trailing zeros. But for this one, it's a leading zero because it's written to the left of the first non-zero digit, which is 8 in this case. So whereas this one is not considered significant, these other zeros will be considered significant, meaning in total, this number has 1, 2, 3, 4, 5, 6, 7 significant figures. Another rule is that trailing zeros, and we have just mentioned here that trailing zeros are those zeros written to the right or to the extreme right of an non-zero digit. So trailing zeros in a whole number with a decimal shown are significant. So if we have a whole number which has a decimal shown, and it happens that we have zeros after the last uh, non-zero digit, then it means those zeros will be considered significant. Take this example. We have 2600. This number has a decimal point here. So the presence of this decimal point makes these two zeros to be significant. And that means this number has 1, 2, 3, 4 significant figures. Similarly, this one, this 100, it has a decimal point, and that means these zeros are significant. So we shall have 1, 2, 3 significant figures. The sixth rule is that trailing zeros in a whole number with no decimal shown are not significant. Here we had with the decimal shown, and indeed it appears here. But for this one, this is a situation whereby we have trailing zeros, but there is no decimal shown. That means those zeros that will be trailing, in other words, the zeros to the extreme right of the last non-zero digit, will not be considered significant. So if we take a replica of this number we have, but with no decimal point, the first one is 2600 with no decimal point. This means it has 1, 2 significant figures. We shall not consider these zeros as significant, and the reason is we don't have a decimal point here. So these trailing zeros will not be considered significant. That means this has 2 significant figures. Now, what about this one? Can you guess this? If we had 100 without a decimal point, how many significant figures does it have? Exactly. It has 1 significant figure because these zeros are not considered significant. Seventh rule is that exact numbers and irrationally defined numbers like pi have an infinite number of significant figures. So when we deal with exact numbers or irrational numbers like pi and these other constants that we use in maths and physics, those ones have infinite number of significant figures. So we have an example here. If we take the relationship between kilograms and the grams, we know 1 kilogram has 1,000 grams. So this is an equation, or these are numbers exposing a relation. In that case, they have infinite number of significant figures. Then the other one that we need to have to know is that for a number written in standard form or scientific notation, if we have a number expressed in scientific notation, then it's only the number that takes this position for A, that will be considered significant. That is the one that will contribute to the significance, the number of significant figures in that number. For this one, it does not contribute to the number of significant figures of that number written in standard form or in scientific notation. So if we take this example, if we decide to take 7,300 and we write it in scientific notation, we can write it in various ways. For example, we can write it as 7.3 times 10 raised to power 3. So in this case, the number of significant figures are 1, 2. So this number has 2 significant figures. We can also decide to write it as 7.30 times 10 cubed. 7.30 times 10 cubed. So we have written it from here to here and then expressed it in scientific notation. So in this case, we have 1, 2, 3 significant figures. And the reason why we are doing so is that the rules that we apply in determining whether or not we should count a number here as being significant are the rules that we have talked about in rule 1 to 6. So for this case, you realize this 0 is a trailing 0, and we said all trailing zeros after decimal point are considered significant. We just talked about it here. Not sorry, here. Trailing zeros to the right of the last non-zero digit, uh, trailing zeros to the right of the decimal are significant. So this 0 is to the right of a decimal, and therefore it's considered significant. And therefore we have 1, 2, 3 significant figures. The last one is this one. So we have 1, 2, 3, 4 significant figures. So that's how we establish the number of significant figures in a number, or the number of significant digits in a number. Thank you.